The definition of direct variation is a relationship between two variables in which one is a constant or a multiple of the other, also known as, if you pay attention, as one of your numbers increases, the other will also decrease, or the opposite, as one of them increases, the other will increase, and then also the opposite, if one decreases, the other will also be decreasing. So when we work through and we look at a table or a set of numbers, in order for a table or a set of numbers to have a direct variation, it has to follow the format of y equals kx, where k is a number that is not zero. And that's what we call the constant number. So when we did our activity for this lesson, that was our slope, or the change that was constantly changing from one point to the other. In order for a set of numbers to be considered a direct variation, they have to create a straight line. They also have to pass through the origin, or 0, 0. So this is just an example of a table that is showing direct variation. And then here's where I've graphed those points, showing what it would visually look like to see it as an actual picture of a direct variation. So we have a straight line that is cutting through 0, 0. And you'll notice here that in our equation, we were able to set it up and solve for k. So for example, if we wanted to solve for k on this one, we would substitute in 3 where our y is. So 3 equals, we don't know the k, but we know that x is 1. And then if we go through and we solve for k, we would divide by 1. Divide by 1, we find out that k is 3. So those are some things that we'll actually be working with in this lesson, is identifying from a table as well as identifying from a graph and an equation direct variations. Okay, so here we're going to tell whether x and y show a direct variation, and we're going to go ahead and graph these out. So you guys will use your whiteboards that you have to graph out these equations. Your graphs are a little bit bigger than mine. So we'll go ahead and graph this out. So the two things that we must have is we must have, when we have a graph or a picture, it has to cut through 0, 0, and it has to be a straight line. So those are the two things that we need in order for it to be considered a direct variation. So we'll go ahead and graph these. So when we graph these, this set right here is the same as saying 1, -2. So that's our set of coordinates. It's just a different way that they've set up a table. This next one would be 2, 0, and so forth. So we're going to go ahead and plot these. So I'm going to go over to 1, down to -2 and put my dot. Over to 2, up to 0. So over to 2, stay at 0. Over to 3, up to 2. And over to 4, up to 4. So we'll notice we do have a straight line. So it does meet that qualification that it is a nice straight line, but it does not cross through 0, 0. So tell whether x and y show a direct variation. This would be a no, it does not. Okay, and if we were to go through and substitute in and see if we can solve for our k, well, that's going to be our slope. So it doesn't mean that we won't have a constant, but it has to cross through 0, 0 in order to be considered a direct variation. So we don't even have to go through and solve for our rule. So we're going to go ahead and do the next one. If we plot this out, well, we're going to go over to 0, up to 0. So we can see that it's already passing through our origin, over to 2, up to 2, over to 4, up to 4, and over to 6, up to 6. So we also have our straight line. So this would be a yes. It is showing us a direct variation. And to figure out what our constant is, well, our x, if we go through and we substitute all of this in, I'm just going to show you one way that you can solve for your constant. We're going to plug these in. So our x is 0, our y is 0. 2, 2, 4, 4, and 6, 6. If I were to go through and say, what was I doing to the first number to get the second number? Well, I can't really test it on 0 because anything times 0 is going to give me 0. So I'm going to have to work with this first one here. So 2 times 1 would give me 2. 4 times 1 would give me 4. 6 times 1 would give me 6. So in other words, our constant is times 1 or just a 1. Another way to do that is to take a set of your variables. So we'll just work off of our 6 here. 6, 6, and we're going to substitute in. So our y was 6 equals, we don't know what k is, but our x was also 6, and now we'll solve for k. Divide by 6, divided by 6k equals 1. And notice how we already had that there. Okay, so that's just a couple different ways that you can solve for k, and we'll be using that second method a little more when we review through this lesson.